So we are multiplying, dividing rational expressions, and then we are adding, subtracting rational equations, expressions, and then we're solving them. So everything in this topic is rational expressions or equations. I told you yesterday, I prefaced this with, we are going to factor. When you have a rational expression, the rational expression itself is a fraction with a polynomial in the numerator and a polynomial in the denominator. That's what it is, okay? We can add them, subtract them, multiply them, divide them. They're just like a rational number, but it has an expression instead of a whole number. One of the things we need to remember is we cannot divide by what number? Zero. So every problem you do, you're going to state the exceptions, the exclusions, or the domain. That would be a restriction on the domain, correct? So I have x squared over x squared minus 9. So in order to find that, I should factor and set my factors equal to 0, yes? What? No. The denominator is all I need. We've done this. We were doing this for like 3 days now, right? 4 days. How do I factor x squared minus 9?
Well, first you set it equal to 0.
How do I factor x? It already is.
Oh, well, it's a...
Take square roots.
It's a thing.
I'm not solving, I'm factoring.
A sum of, or a difference of squares.
It's a difference of squares, yes?
Yeah.
X squared and 9. So that factors to conjugate pairs, yes? So it factors to x minus 3 and x plus 3. And then I would set both of those equal to 0 and get the domain of x such that x does not equal what? Okay, have we been doing that?
Yes, ma'am.
Yes. Okay, my hope is I get you your tests back and your quizzes back after we're done with this today. So hopefully if we can remember how to factor, we'll get through it. Okay, so equivalent rational expressions should always be reduced or simplified. If you got an answer of 12/16, is that completely right?
Yes. No.
Why not?
Reduce it down all the
It
way.
has to be reduced or simplified, yes? So what factor do they both have in common?
4.
4. Okay, so if I reduce them, if this was 4 times 3 and this was 4 times 4, I'd reduce the 4s to 1 and have what?
3 over 4.
3 over 4. Now you don't do it that way, do you?
No.
You just take it. But is that what's actually mathematically happening?
Yeah.
You are factoring a number and reducing the factors that they have in common. So when we have polynomial rational functions or expressions, we are going to factor and reduce. This is one whole thing in the numerator and one whole thing in the denominator. You cannot, and there should be an X there, you cannot reduce any one part. Could I reduce the entire polynomial?
Yes.
Yes, but I cannot reduce those things individually. We've discussed it before, and I'll remind you. A fraction bar is a grouping symbol. It just has as much power as parentheses or brackets. So it means I have to do what's on the top first, and I have to do what's on the bottom first. So can I add x cubed minus 5x squared?
No.
No. So if I can't do that, I don't have an opportunity to reduce them out individually because I can't get past the first step. But if I could reduce the whole thing, I am okay. If I can turn this into a product, I can reduce the factors of the product. So that means I have to what? Factor. Okay? So, how would I factor the numerator?
Take an X out.
I would take an x out.
And you got -8 and +3.
And then this would be a 2, and this would be a 1, and this would not be anywhere. Yes? Okay, so now I have, there's a 1 out here, so 1 times 24. 24, factors of 24,
8,
that have a difference
A
of 5.
5.
-8
-8 and 3.
and 3. And how do you know it's -8 and +3?
Because the middle term is negative.
Because the middle term is negative. Everything we've been doing on factoring, and your ability to do so is going to save you a lot of time. If you struggle with factoring, is this assignment going to take you forever and a day?
Yes.
Yes. hopefully, eventually, your factoring is going to get good. Okay, so on the bottom, in the denominator, let me use the correct vocabulary. What should I factor out? An X. Always factor out if they have something in common, yes?
Yes.
So then that makes this a 2, that makes this a 1, and that makes that gone. So I got a 1 in the leading coefficient, so 1 times 72 is 72. Factors of 72 have a difference of 1. 9 and 8, which was positive, which was negative.
9 is positive, 8 is negative.
Hey, did you ever think you would factor that fast?
Yes.
Oh, yeah?
You did?
Cause I'm a baller.
Okay, now, have I turned that in to a product? Well, I'm turning it into a multiplication problem, correct? So now I can reduce out complete factors. So, what do the numerator and denominator have in common?
X
And X minus 8.
X and X minus 8. So when I reduce, things go to 1, yes? Or they could go to 2 or whatever if they were appropriate. So now I have 1 times X plus 3. So I have what? X plus 3. And I'm still going to suggest that you put parentheses around that. So you stop your brain from trying to do anything. Because can I do anything with that? No, not unless I do it with the whole thing. It's stuck together. Over what? X plus 9. Now, can anybody think of a mistake somebody might try to do?
They might try to change it to 1 over 3.
Yeah. I've seen this answer when they get here. This is a no-no. Don't write it down. Got it? They get here and they go,
I mean, checks out, really.
Hold up.
What?
what did I do? It's completely wrong, correct?
Oh, you added the.
Because I have an X and an X, yeah. Uh-huh. So there was 1 and 1. And then I had a 3 and a 9, so that's 1 and 3, right? Well, there's a plus in the middle, so I added them. And the response I've gotten, I said, why did you do that? Well, I just did what it said to do. No,
That was smart.
that's not how that works, right?
Well,
Can I do that? No.
You're making it seem like
You're
it's better
totally
than
not
me.
wrong.
I can.
No. You would get that on a test. No, and probably some tear stains on the paper. Okay, so my answer is X plus 3 over X plus 9. And if you put those parentheses, they will help you stop from doing that.
So you just leave it like that?
That's it. There's nothing else we can do.
Beautiful.
But we need to state the domain. And I probably should have done it before I started marking things out because I have to come back here. Not what is left when I'm done. Because when I'm left with I'm done, I would just say negative 9, correct? But what about 0? Would 0 have made this whole thing 0? Yeah? And what about 8? Would it make the whole denominator 0? Yes. So you have to do your domain based off of what you've, before you've reduced. Okay? So, this would be negative 9, 0, and 8. Now, when I graph this, because I could graph this, yes, the only one of those that would be a vertical asymptote would be negative 9. Okay? Where do I get the 0? Because there's an X in the front. Okay. Again, the only one of these three that would be a vertical asymptote would be the negative 9. Remember how I told you that every exclusion would be in your domain, but it wouldn't always be in your vertical asymptotes. What happens is we reduced out the 0 and the 8, didn't we? Now, if you guys remember back to yesterday, how did I find x-intercepts? It was the zeros of the numerator, correct?
Yeah.
Okay. And by definition, a vertical asymptote is something you cannot cross and you cannot touch. Yes?
Yeah.
Well, my numerator shares 0 and 8, doesn't it? Could some value be both an x-intercept and a vertical asymptote? Is that...
No.
No.
Because you can't cross
I
it
can't
and
cross it
touch
and I can't touch it. So could something be both an x-intercept and a vertical asymptote?
No.
No. So in that case, it's neither. It's not an x-intercept, and it's not a vertical asymptote. The only vertical asymptote of this would be -9, and the only x-intercept of this would be -3. Because of the 8 and the 0 being shared between the numerator and denominator, they cannot be anything else. But it does limit the domain. It's the only part of the problem that affects. So, all of your examples are here not because I think we need more and more and more and more how to multiply, divide, and simplify. It's because you probably need to see some different factoring, don't you?
Yeah.
Yes. Okay, so the first thing I always do is factor, every time. So the numerator,
Difference of squares.
difference of squares, does everyone see that? 4 and x squared. So it factors to what?
2 plus x. No,
2 minus x and 2 plus x. You have to keep your 2 in front.
Hold up. Wait, never mind. I figured it out.
You got it?
Yeah.
Okay. Is that better?
Yep.
Okay, now my denominator. Factors of 10 that have a difference of 3.
-5 and
Five
-2.
and -2.
Okay, so 5 and -2. So at this point, my domain is going to be what?
-5 and 2.
-5 and 2. Only what part of this function? Denominator. I don't care. The numerator can be 0 all day, can't it?
Yeah.
Okay, so only -5 and 2. And I'm not done, but if I do my domain now, then it helps because I haven't crossed it off and my brain doesn't forget to do it.
It'd probably be 5.
Okay. So, anything reduce?
-2, or the negative x
Don't
minus
think
2.
so.
No,
No,
because
no,
they're
because they're
around each other.
2 minus x and x minus 2 are two different things,
Yeah.
aren't they?
Yep.
Yeah.
So, but can I move things around? Can I like switch the terms in the
Yeah.
quantity?
Yeah, but you have to do something
Okay.
special.
So I do
You
have to do
take the
something
sign
special.
with it.
I can do this, yes?
Yeah.
Okay? So I changed this, but now I have negative, I still have negative x and positive 2,
Just shoot.
but can I factor out a negative?
Yeah.
Yeah.
I can factor a negative out of there, can't I?
Yeah.
Yeah.
Okay, if I factor the negative out, I get negative x minus 2, don't I? Don't I? So it's -1 times the quantity x minus 2. So now do I have x minus 2 and x minus 2 that I can reduce? But I can't forget I still have a what out here?
Negative.
Negative. So now this reduces. So I get negative 2 plus x over x plus 5. Now, question for you. Can I move around that x and that 2?
Now you can, yeah.
Well, I mean, can I? What makes that one special that I can just move it around?
They're both positive.
They're both positive. If they're both positive, can I just move them around anywhere I want? If that bothers you, could you write it as negative x plus 2 over x plus 5?
Yeah.
Yeah.
Seems like it.
Does it matter? No. You're still doing it the same question, the same answer. So the domain and that simplified is your answer.
So,
That is going to happen 2 or 3 times in your homework. And it's going to happen 2 or 3 times in your examples also. Okay, probably it'll happen at least once. Because that's a special thing that we can do. Okay, numerator,
Which one are we looking at?
this one.
Numerator 1,
1, 1.
positive 1.
We get going too fast, you guys have to say something.
How'd you do that?
Factors of 1 that add to 2. Okay, now in the denominator, I can factor out a what?
X.
An x. So that's 2, that's 1, and that's gone.
Yeah, negative 3 positive
Factor
And then factors of 3 that subtract a 2,
would be
negative 3, and
1.
Positive 1. Wait. What if there's things that
then there's 3 things I reduced. Okay, so domain is
do is
0 up to
negative 1, 0, and 3.
Yeah.
And those should be written from littlest to smallest. That is one thing that should happen in domains.
How
Okay.
do you figure out the domain?
Set all the denominator equal to 0 because I can't divide. I should not have underlined that. I cannot divide by 0. I set every single one of these factors equal to 0. Like we've been doing with the rational functions. Because if I want to know what makes them 0, I have to set it equal to 0. Okay, now I only have, I know what you're asking now. I can only reduce one of these x plus 1s, correct?
Yeah.
Because I only have one x plus 1.
Uh-huh.
If I had 2, could I reduce both of them?
Yeah.
Okay, if I have 8 over 2, I can't reduce all the 2's in the 8, can I? No. Okay, so anything else? No. So my answer is just x plus 1 over x times x minus 3. Now I want you to leave them multiplied out. I don't want you to distribute that today, okay? Because I want us to get in the practice of making sure. And this, if you leave it factored out, can I see immediately if you've left any factors in there?
Yeah.
Yep. Okay. X cubed plus 4x squared minus x minus 4 over x squared plus 3x minus 4.
The top one you can't factor out of it.
Top
Top one can't you like factor by grouping?
The only way I can do the top one is factoring by grouping, right?
Yeah.
Okay. So factoring by grouping. So which ones do you want to group?
The
First
first
two
two
and
and the
last
second two.
Okay. So what are you going to take out of the first two?
X squared.
X squared.
X squared, and then you get x plus 4.
Yes.
Negative.
And then a negative. So you get x plus 4.
So that would be negative 1 in the middle.
So you now have x squared minus 1 plus x plus 4.
Yeah.
Okay. Am I done factoring the numerator?
No.
No, because you have a difference of squares.
Because I have a difference of squares, don't I?
Yep. So,
Now, if that was x squared plus 1, would I be done?
I mean, unless you really wanted some.
We're not doing imaginaries. We're only doing real numbers. So would I be done?
Yeah.
Okay, so this can still reduce to,
Plus minus 1.
so I have x plus 1, x minus 1, and x plus 4 for the numerator. And my denominator, factors of 4 that have a difference of 3.
Positive 4 minus 1.
Okay, so why would it be x plus 1 and x minus 1?
Because x squared minus 1 is the difference of squares,
Okay.
that conjugate pair. So what can I reduce?
X minus 1, x plus 4. Reduce to x plus 1.
And so all this reduces to 1, yes?
Yeah.
Oh, I
Our
forgot my
domain is-
domain. That's okay. We'll get it.
Negative
So I just get x plus 1, don't I?
4. Yeah.
Can I put it over 1 if I really need to?
For some reason.
Yeah,
sure.
but should I just know it's over 1?
Yeah.
Yep. And what's my domain?
X such that x can equal negative 4.
And again, I probably should have done it before I crossed them out.
It's okay.
As long as you do it, it doesn't matter when you do it. Questions? Because this is the premise of everything from here on.
That seems pretty good.
Okay, the hardest part of these problems are gonna be to what? Factor. Okay, so when we multiply rational expressions, the top one's just an example. All of that in the numerator is multiplied, all the denominator is multiplied, correct? So when I reduce, I can reduce up and down and what? Diagonally. Can I reduce side to side?
No.
No, that's multiplication, correct? Okay, so what can I reduce here?
Why?
A y? Whatever, I crossed it out.
Oh, 2, 4.
I'm
One
too
over
high. 2 and a 4. Oh, that's horrible. Can I reduce any x's or z's?
No.
No. So it's going to be 3x to the what now? I got 2 and 1, so
Oh.
it's
Cube.
cubed. And 2 z to the second. I apologize. Anything above my bar, the pin is not right where it's supposed to.
I was really trying to figure out what happened to that y and why it's still there.
It's not. It's gone. Hopefully
Yeah.
you crossed it out right. I need to mess with my. Come down tomorrow and the projector's on the floor. It's because we got to fight.
You and the projector?
Yep.
Who won, the projector?
No,
the
evidently
projector's
me.
laying dead on the floor, so.
Definitely the projector. 'cause it's
And what if
on.
you are laying down on the floor?
That would be
It's
Guess
still
I don't
not
have to
the
worry about the projector anymore. Okay, so now I got all these rational expressions multiplied times each other, right? Yeah. So I gotta know that this is in parentheses, yes? And so's that. So what do I have to do to everything?
Mush them together. Tribute.
I'm gonna multiply them all together right now.
Well, I guess you could factor.
You probably want to factor and do what Reduce. before you multiply, correct? What have I been trying to do every time when we have fractions? I've tried to get you to reduce before you multiply, correct? If you were to multiply all this out and then have to reduce it, would that be fun?
X to the 5th.
Yeah, we'd be trying to factor x to the 5th, and you'd have to do long division, and it wouldn't happen, would it?
What about something?
No.
There's X plus 3.
Okay, so is 5x good?
Yeah.
Is x plus 3 good?
Yeah, that.
Okay, we're good there.
Gucci.
You get here. You guys factor. You guys factor.
Hoping.
I want to factor with you.
Well, but some people want to try to do it on their own. I know they do.
Also have notes.
Well, he was learning yesterday. He should have had notes, but he's still not taking them, so he didn't learn his lesson.
Yes, wait.
The day before, you should have learned your lesson.
Actually, I looked at someone's notes before the quiz.
And you still bombed it.
No, I just messed up the division.
Bombed it.
Bombed it.
Bombing it.
I redid it though.
Actually, you messed up twice, and half your answers were right.
Actually, yes.
Wow.
You.
But you still have
That's the most Evan thing to
Solid
do.
skill right there.
How did you manage to do that?
Because he messed it up both times.
Okay, but half his answers were right. Think about that part.
You guys got factored yet?
No,
Then
I
yes.
just got 79.
Focus.
I'm sorry, I put it on.
Do I still have to have these big parentheses?
Yeah, I mean, it makes it look
Couldn't I
better.
just do this?
I don't know.
No.
No.
Why not?
Because they're all individual problems.
They're all what? Multiplied, and don't the parentheses in between them tell you they're multiplied?
Yeah, but still, it looks clean like this.
I don't know. What do you want us
Don't
to
you dare
say?
do it.
Well, no, I'm just asking you if I can, because you guys are always like, you gotta save your graphite because you think it's
Well,
too expensive.
Of course I do.
Well,
You gotta save your eraser and
You can't even erase the thing.
Yeah,
It's too small.
you can't.
it's probably, it's either too small or too big.
Oh, that time it's neither. Oh, perfect.
What is-
Look at that.
She just can't trace very well.
Yeah. And she left half of it. It's fine. It doesn't
Okay.
matter.
I didn't.
Oh, you grabbed the
Top part. Now we have
So-
14. That's not good.
What?
Didn't I just write the same thing?
Yeah.
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 I don't like the big parentheses there, but I definitely won't, like, if there's a dot to show multiplication or an X to show multiplication, that's even worse. Okay, did you manage to get it all factored?
No.
Except for the numerator of the other one. I had another X and I knew it wasn't right.
Oh, okay.
I would have got there eventually. Maybe.
Does everyone know how I got what I got?
Not really.
Not really.
Okay, so factors of 6 that have a difference of 1 are positive 3 and
Oh,
negative.
I could do that.
I
It's
knew
the
that
last
one.
one.
Oh, I just factored out an X.
And then-
So X and X plus 1. And then I factored out a 5. So X minus 2.
Yeah.
Oh, okay.
And I don't understand why I can give you guys a trinomial and you're like, ooh, I can do it. And then I give you a binomial that you just factor one thing out and your brain shuts off.
Or it's a trinomial.
When
Because
it-
they
okay.
think it's too easy.
A binomial has how many terms?
Two.
When I look at a binomial, the things I should be saying, is it a perfect cube, is it a perfect square, or does it have something in common? Because do I have rules for perfect cubes and perfect squares? Yes. So I have rules for perfect cubes, perfect squares. And if they're not either one of those, do they have something in common? And if they don't, then it's not factorable.
You know why we're so much better at trinomials? Because there's 3 and we know what they have to equal.
Yeah. The other ones, your brain wants to do too many things to it. Okay, what can I reduce?
They're gonna say some stupid.
You
because we
can
don't
add
know
X plus
something.
X plus 1?
Yeah.
How about an X plus 3?
Okay.
X minus 2.
An X minus 2?
No, you can't do that.
They can.
What, can I take a 5 and a 5?
Yeah,
I
yeah,
did
that's
that
an
every
X.
time my hamstring
No.
was
Oh wait,
breaking.
never mind. That's side to side.
Side to side.
Dang.
So now you have
X
x squared
times
over
X squared over X plus
x
1.
plus 1.
X squared over X plus
I
1.
forgot the domain.
Yes, we did forget the domain.
Ah, it'll pop.
You forgot the square root too. Thank you.
You're welcome. We forgot the domain. Okay, so this was what?
3 x.
No.
Oh,
Negative 3. Because we have to equal them to 0, yes?
Yeah, and then negative 1.
Negative 1 for both of them.
Yeah. And then
That's nothing. Why is this nothing?
Because
then
you
you
said
fact-
equal
you
to
use the
0, it
factor.
doesn't equal.
Right. If it had a what?
X.
X would be. What's this?
2.
2. So my domain is X cannot equal.
Negative 3, negative 1, divided 2. Why did you have a 0 in there for the 5? I feel like you just have a 0.
It's nothing.
We just had this
I
discussion.
know, but I just feel like you should have a 0 there.
5 equals 0. Does 5 equal 0?
Yeah, no.
No. 5x equals 0.
Yes.
Yes. Because I can plug a 0 into x and get 0, right?
Yeah.
But can I do anything to 5 to make it 0? No, because it doesn't give me anything to do. You can. You just put an x there. It's okay.
Video 0.
Okay. Now, I think I put too much on one slide, but then when I went back to change it, I accidentally deleted the actual PowerPoint, so I have to remake everything. So I didn't do that over lunch. Okay, so we're going to go bottom, like top, bottom, over. Product. What does product mean to do? Multiply. Okay, this is just x cubed plus 4x minus 12x. Is that a rational expression?
Yeah.
Yeah, because it's over what? A 1. So it's the same thing, it's just over 1, right? One less thing to factor. Yeah?
Now fancy.
Yeah.
Okay, what am I going to do with x plus 2? Anything?
Leave it.
Leave it.
The bottom difference cube. Squares and then squares again.
X plus 2 This is difference of squares, but it's gonna be squared, yes?
Yeah.
You like squared.
Now, can I factor x plus 4 further?
No, you'll get an I.
I'll get an I, it's no good, I'm not gonna touch it. So it's gonna be x squared plus 4. Can I factor x
Yes.
squared minus 4 more though?
Plus 2 minus 2.
Now personally, I would just extend this and put this right next to it. Because I can, right? It's multiplication.
Yeah.
Okay, what do I do with x cubed plus 4x squared minus 12x?
Take out an X,
Factor on x.
and plus 6 minus 2.
So that becomes a 2. This becomes a 1, and that's gone. So factors of 12 that have a difference of 4.
Plus 6 minus
2.
And you got 5, and you got 5.
So what can I reduce?
X
Minus
plus
2.
X minus 2.
Don't say that sink ever again.
Domain, right?
Oh, sure. So,
-4, -2, and 2.
Oh, wait a second. That is x squared plus 4.
yeah, it'd be imaginary.
It should be imaginary. So do I state that in my domain?
No.
No.
So
Burn.
it'd just be
Fire.
So it would just be
-2.
Negative 2, 2.
negative 2 and 2.
Plus or minus 2.
Now I don't have a whole lot of room. I way put too much on the slide.
And then so,
So
your
it's
and
just x.
x plus 6, x plus 6 over x squared plus 4.
And again, if I put those parentheses, is it going to stop me from reducing things that I can't reduce?
Maybe.
Hopefully.
And for the top one, you'd have to put parentheses anyway.
Okay. This one,
Well, actually, this one,
numerator.
numerator, you could factor out a, no,
X.
that's it.
An
And
X?
the difference of cube.
An
X
X?
squared, yeah.
Okay, if I factor out an x, I'm left with x squared minus 4. Yes?
Mm-hmm.
Then you can,
But I want to show you something. Not always the best thing to keep going, because I can keep factoring that, yes?
Well, yeah, but you.
But what is the bottom going to factor
X
to?
squared minus 2, X squared minus 4,
so the
Or
x squared
plus
plus
4.
4.
Right, so it's going to have the x squared minus 4 in it, right?
Yeah.
Yeah.
And if I kept doing with the numerator, I'd have to keep going with the denominator, and we like to save time, right?
Yeah, so why don't you take
So-
x squared out of it?
I can factor the denominator to x squared minus 4 and x squared
Plus
4. Plus 4.
4, and I can save myself some time.
Yeah.
Did everyone see that?
Yeah.
Okay, we took an x out of the numerator, and we're left with x squared minus 4. But we saw the bottom was a perfect square as well, but we're going to have x squared. So it's going to be x squared minus 4 and x squared plus 4. So as long as these are the same quantity, we'll be able to reduce them. So we don't have to keep factoring. We can stop and save ourselves time. If I found one that was a trinomial, matched a trinomial, could I stop and not factor? Yeah, because the whole thing, as long as the whole thing reduces, I'm good to reduce, aren't I? Okay, so now I have this. I can factor out a what again?
X.
X. I probably shouldn't do that because maybe I can't factor it. So this is a 2, a 1, and a nothing. So now I gotta do this factoring further. I have to go 2 times 5, yes? 2 times 5 is 10. Factors of 10 that have a difference
Negative 5.
of 3.
2.
Negative 5 and 2. So I need negative 5 and I need 2. But I need to remember when I multiply, and this is why we were doing what we were doing yesterday, because they had made you think about the multiplication, right?
Yeah.
The 2 has to go 2x and x here, correct?
Well,
Yes?
Yes.
And if I want to end up with 2 and 5, I've got to have a what right here?
A 2.
5.
I want a 2 and a 5. If I take 2 times 5, I don't get a 2 and a 5.
You want a 2.
I want a 2, so what do I have to take 2 by to get 2? 1. Yes?
Yeah.
And then this right here needs to get me my 5. So I have a 1, so what has to go here? 5. So you have to be multiplying while you're dividing or factoring if you want to do this. If you want to go to the side and do your grouping all the time, then you can. But if you don't start going more proficient, are you ever going to get through these assignments in a reasonable amount of time?
Do that one more time.
Okay, when I factor, I know that this is the factors of A, this is the factors of C, and this times this, and this times that give me B. Combined, yes?
Yeah.
So, A is 2.
Yeah.
The only factors of 2 are 2 and 1, correct? So I need to, when I do this, and I do this, I need to come out with negative 5 on one of them and 2 on the other.
So 2x.
So 2 times what gives me 2? 1. Is 1 a factor of 5?
Yeah.
Okay?
Yeah.
And I need 5 for the other thing, don't I?
Yeah.
Good thing. So 5 times 1 is 5.
I don't know why that was so hard.
I don't either. Okay, so I can reduce what?
And then,
Oh, domain.
Plus or minus 2.
Now this is going to be imaginary, yes?
Yeah.
Not going to be any good? But this does factor to x plus 2 and x minus 2, doesn't it? So plus 2 and minus 2. Guys, if you would have factored that completely out and factored that completely out, you would have been fine, right? They're still going to do what? They're still going to reduce.
Reduce. That's what I meant to say.
Okay, anything else going to reduce?
no.
Nope. So I have x squared times 2x plus, not plus, minus, right?
Yes.
Minus 5, x plus 1 over x squared plus 4. Okay, 3x squared plus 6x over x squared minus 49. And then times x squared plus 9x plus 14.
The bottom one's a difference of squares.
Bottom one's difference of squares. Everyone see it? Once you start seeing them, your life does turn out easy. So x minus 9 and x plus 9? Yeah. Yeah, that's a 9.
Yeah. Yeah.
I
Okay.
think I'm seeing 49 and just saying 9. At least I matched the 9s and did conjugates, right?
Has it been a good
I wrote it right. That's all
It's
that
been a
matters.
very long day for you.
Evidently. Okay, 3x squared plus 6x.
3x.
3x. So I get x plus 2.
Yeah.
Okay, factors of 14
2,
that
7.
add to 9. Kale, you need to quit saying those out loud, please. I think other people may not be able to have time to think.
But I just want to feel good about myself.
I know.
Don't make us feel bad on ourselves.
Does he need to count to 10 and then say it, guys? Don't count to 10.
Yeah, no. Don't
Kind of aggressive.
That was okay. Anyway, factors of 14 that add to 9 are 7 and 2. Correct? Okay. If I know my multiplication or factors much easier,
Yes.
Yeah. why am I so against calculators? I wonder. Okay, now what?
Reduce.
Domain.
Domain? Reduce. Which one?
Domain.
Domain?
Plus 7.
Plus or minus. Thank you very much. And you wanted to do it first. Okay, now what reduces?
X plus 7.
Wait a second. But you couldn't reduce straight. So it had to be diagonal.
We are reducing.
Up or down
Oh.
or diagonal. I just wrote it as one thing. Now, how did I write that? X plus 2 squared. Why could I do that?
Because you
Because
have
there's
no
two of them, just like if there was two X's, right? See, I'm saving your graphite. Okay,
I'm saving my graphite.
now we get to divide. When I divide fractions, what do I multiply by?
Opposite. Well, the
The
reciprocal.
reciprocal. Yay! Okay, not the opposite.
I will always say
That's not right. Okay, I reciprocate which one? The first term or the second one?
Second.
Second, because it's 6 divided by 2, right? 2 is the divisor. You reciprocate the divisor. But other than that, do I do anything that I just got done doing? No. I'm still going to factor, and I'm still going to reduce. Okay, so they wanted you to see quotient, just so you knew that was division. Okay, so x cubed plus 3x squared, that is not even enough room. We are not going to do that problem yet. We're going to do that problem, but we are not going to do it there because it's not enough room. I'm going to have to add another slide. So you can write it down because then you're going to tell me what it is. So we're going to take x cubed plus 3x squared plus 3x plus 1 divided by, over 1 minus x squared, all divided by x squared plus 5x plus 4 over x squared plus 3x minus 4. So I had like a division problem. I have 2 division problems and 1 division problem, don't I?
Yeah.
Because a fraction is a division problem, yeah.
Yeah.
Okay, but we are going to do that. That is just not enough room to do it right there. Okay. Okay, we ready to go to next ones? Next ones look better, don't they? I think they look better.
Oh, I see what's going on.
that top one looks very confusing.
The top one is going to be a chore to factor. I will tell you that.
Which one are we getting then?
We'll go down.
It's a different. Well, we can back out of the next.
Okay. So, what can I do right here? Anything in the numerator? No? Denominator? X? Yes? So x and then x plus 9. So now it's going to turn into a multiplication problem and I'm going to reciprocate, yes?
Yeah.
So I'm going to move my numerator to the denominator. Can I factor it? 6 minus x, can I factor it? No. Okay. What about 3x squared minus 18x? A 3x. So if I take out a,
What are you doing?
We're watching Ted Lasso, that's what we're doing.
I'm not doing anything.
So,
The wonderful Wi-Fi did.
No, it wasn't falling.
No, I don't even know what happened because it should.
There's
It's still
sign.
connected.
It's a sign.
Still recording. Still connected.
Looks like we have to stop.
The stars are aligned. We